Okay, so gagawin natin next is ito. Overlapping. Okay. Well, stream today we're going to discuss the first part of College Chemistry 1, the evolution of the atomic structure. So, here is the timeline of the atomic theory. It goes way back to 400 BC. This is the ancient times. Basically, here is the Greek model of Democritus, rather. And there's Aristotle's four elements. This is an overview. Aristotle's four elements, which is fire, water, earth, and wind. The Fire Nation attack, yeah. Dalton model in 1803 was the first basically proper model of the atomic atom, and then there's it just evolves, goes on. Thomson's model, which is the electrons, the Rutherford model, which is the I think it was the neutrons, protons. Either of these two are protons and neutrons. Then we have the wave model, modern, or I guess the quantum. So moving on, there was a big debate. Can matter be divided into smaller and smaller pieces forever? So we will move on to this question as we go through. What's this? What the fuck? Anyways. So the theory of Democritus says that matter could not be divided into smaller and smaller pieces forever. Eventually, the smallest possible piece would be obtained. This piece would be indivisible. He named the smallest piece of matter atomos, meaning not to be cut. Basically, atom, the word itself means it can't be cut anymore. So going back to this question, can matter be divided into smaller and smaller pieces forever? Actually, we will not find out yet, since this one is the first part of the theory, which is the ancient theory. So the word atom comes from a Greek word that means unable to be cut. The word atom comes from a Greek word that means, wait, what the fuck? It is just goes again. So anyways, this one basically divides gold to an atom of gold. Basically dividing it, pam 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 pam. Then the atomists, which is Democritus, and who are you, bro? Are you Lucius? Is that Lucius? Leucippus. Leucippus. I don't know. That guy isn't important, so we should probably move on. So matter is composed of atoms, basically indivisible. Wherein Aristotle and Plato favored the earth, fire, air, and water approach to the nature of matter. The atomist idea was buried for approximately another 2,000 years. So basically, BC, the ancient times, atomos wasn't as popular as how Aristotle and Plato, you know, like Aristotle and Plato, the four elements, they loved that idea more. They liked that idea. It was magic to them. It was magic. So, anyways, for another 2,000 years, we wouldn't see the word atom again in popular science culture. So, anyways, Dalton model 1803. 1803. What was in 1803? 1803 was like after the Renaissance. This was more of Enlightenment age, wherein, yeah, we have guns, like more modernized military, and people were doing a lot of things. Basically, science was growing during this time. So 1803 Dalton model, he basically put the billiard ball, and then, this looks like an atom. It's a sphere. Yeah, it really has no experimental evidence. It was just like a theory to him. So all elements are composed of atoms. Atoms are indivisible and indestructible particles. This is a theory. Take note, this is a theory. Atoms of the same element are exactly alike. Atoms of different elements are different, and compounds are formed by the joining of atoms of two or more elements. This is the Dalton atomic theory, listed here as how he would describe an atom. But this could differ from every each theory. As you can see, no, as for how we experience chemistry throughout, there are some facts over here that are not true. This is because this is the 1803, the Dalton atomic theory. So we'll be moving on, and um we'll be comparing these facts to how the future, the modern chemistry works. So here we have the Dalton 1803 Thomson. We'll be moving to that. So here's J.J. Thomson with the discharge tube experiment. So he rather discovered electron, wherein he put this, is that E over M is equals to negative 1.6 times 10 to the power of 8 C over G. So we have the negative electron and the positive charge spread over the sphere. So keyword over here, plum pudding model of the atom. So J.J. Thomson plum pudding electrons are viewed as a plum. Yeah. So Robert Millikan, I think it was the oil drop experiment. Yeah, oil drop experiment. He described charge of an electron is E is equals to, you know what? That's E over M. This one is E is equals to negative 1.6 times 10 to the power of negative 19. C. What the fuck is C? Anyways, Ernest Rutherford alpha scattering experiment, the nucleus. So this guy is J.J. Thomson discharge tube experiment, and Robert Millikan is the oil drop experiment. E is equals to negative 1.6 times 10 to the power of negative 19 C. Okay, so alpha scattering experiment. Ernest Rutherford discovered the nucleus, which the nuclear model of an atom, finding its mass of the atom is concentrated in the small volume at the center. The nucleus occupies only 1/10 at the power of 13 of the volume of the atom. Really? So E. Goldstein, tangin. Hindi ko na kaya. Putang ina.
Stoner.
Hindi ko na kaya. Solar system model, Bohr Summerfield model, 1916, blah 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 blah, quantum mechanical model, blah blah blah, the atom family. Yay! Ready to memorize this? Wow. Kanina mas maglibog guro ka na. Anyways, atomic symbol notation. Ito yung pinaka-important. So we have X equals to elephant, Z is equals to atomic number, and A is equals to mass number. Example. Nabuhat mo ko ni last month ba? Hindi ko na kaya. Gusto ko na lang mag-stream.
Naya po! Napantay, oy! Naya po!
Yawa.
Nasunog!
Gago.
Nasunog! Nasunog ko!
Uy, gago. Yawa. What the fuck? Uy, bobo.
Tanawa, natrabaho niyo lagi?
Yawa.